I am the CEO and the Chief Executive Officer, of course, of MVIT, as well as the President. I have 20 years plus in experience in IT. I've worked with the big tech, Microsoft, IBM, Capgemini, DSL, and Ericsson. My experts are cloud solutioning and then artificial intelligence. I build model, design model, and stuff like that. I work cold time mostly with Idowu, who will work together in MVIT, New Vision Institute of Technology. And we focus basically this year providing hands-on experience and training for people who want to either switch on or edge up in artificial intelligence and machine learning from us as we build in the cloud. Basically, for myself, like I mentioned, 20 years plus in the industry, a couple from Microsoft, where I did a lot for the company, IBM as well. And then it may interest you that I'm one of the Microsoft valued professional, especially in the AI industry, as well as a supporter and a mentor with Stanford University Startup Hubs, where there are founders who are interested in building startup around artificial intelligence. I am one of the mentor over there as well. So build a lot of product. That is my LinkedIn QR code. If you want to get that, you can actually get that as well. So yes, this is what I do. This is what I build across the cloud from AWS, Azure, and GCP. I do a lot of all that. Hand over now to Dr. Idowu to continue introducing himself. Thank you.
All right, good afternoon, or morning or evening, wherever we are. It's nice to be here, and thanks for hosting us in this program. So without wasting much of my time, I would like to just introduce myself briefly. I'm a researcher, I'm a research scientist, and have worked in the industry and also have worked in the research centers. And currently, I work in both sector as well. So I have over 15 years experience spanning in the academia industry and also consulting. And my expertise lies in the brain-computer interface, where I helped children with disabilities, those who have quadriplegic, and they can't actually use their arm or any part of their body. So create an alternative approach to using every other part of their body, which is using their brain signals, and then they are able to use artificial intelligence to be able to control their arms and they move in. So basically that's what I do. And also I develop models, AI models, that cut across different organizations and industries. So, and I've also held different responsibilities, like in IEEE. I'm an IEEE ambassador in the North America and specifically Canada. And I'm also a faculty mentor for the Black Youth Mentorship and Leadership Program in Canada. And also, I was the postdoc committee member for brain-computer interface in Canada. So, and I've also received various grants, awards, and recognitions, and also funding. So, also I'm a cloud architect, that's Google's cloud architect, and also a Microsoft's Azure and data engineer as well. All right, thank you.
Thank you so much. So the way it's going to run, Dr. Idowu will start the first side, and then I think I'll allow him to share his screen from there. Then again, I will start. I will later come to continue the second half of the game. But over to you, Prof.
All right, thank you very much, sir. So once again, thanks for having us and giving us the platform to also help others. We are passionate about helping people come into tech and also drive, the AI solution for different or various problems that we are facing across the world. It's not only limited to Nigeria, it's also in the overseas as well. So it's an opportunity to have each and everyone here. And then I believe that the time we're going to spend, though it might be very little, but just grabs one or two things, and then we can have conversation later on as Engineer Enoh will be giving us ways you can contact us. So please, can I share my screen?
Yeah, go ahead.
Okay. All right. So, all right. So, today, I'm going to be discussing briefly about AI and ML, just to formally introduce us to AI and ML. And then we are going to dive deep into the practical, which is the hands-on, which is very critical in this specialization, this field. So to start with, we are all familiar with AI. We see the name AI comes up everywhere, and you imagine what is this AI? It depends on the scope at which you view AI, artificial intelligence. I could tell you vividly today that the scope of AI is emerging and is quickly emerging. Imagine in the sense that it is not limited, it is limitless. So though currently there are scopes, we have it to have extended to, but I will tell you that in the future the scope continue to widen. So the better it is for people to get into it and then be able to explore various opportunities that we have in it. So artificial intelligence, like you say, is trying to mimic what human being does. So we know human beings, we have the intelligence, and then we have all where to do things at our own discretions. And the same thing applies to artificial intelligence. But it needed an historical event to be able to tell us an event around it. So mimicking humans' intelligence, mimicking humans' behavior is what artificial intelligence is. So, but you needed to put you need to to give it an information which is in form of data, and then it does use the data. It use the data to know what is going to happen and in the future event as well. So just to do an illustration for us to have a better grasp of what the AI is. So I liken it to be like in a kitchen. We have a house where you have a kitchen, and then we have various rooms and then various components in the house. So I'm just looking at the kitchen as it were. So when you look at the kitchen, we have various things in the kitchen. For instance, we have someone who is coming to learn how to cook, and the person has no prior knowledge of cooking. He has no prior knowledge of the ingredients. He has no prior knowledge of any form of cooking experience or whatsoever. So now he's coming new as a newbie to come and learn to cook. So when it comes to learn to cook, later on, it becomes a master chef. But before he gets to become a master chef, he would have learned to cook for a period of time. So he's learning to cook, losing all the informations, all the ingredients, all the infrastructures that are available in the kitchen, like the cooking utensils, the spoon, the knives, the plates, the pots, all the ingredients. So he used this over time, and then after a while, he became a master chef. Then after that, he chooses the correct ingredient. He can do that as it's because he already has the experience. So now he doesn't need to look at the bookery, or he doesn't need to look at any information to get the ingredient to mix together. Now he's a master chef. He knows the amount of ingredients he needs to put in. He knows the quantity and all that. So he chooses this at his own discretion and as a result of his experience. Then also he has the book, a cookbook. So he can produce a cookbook based on his experiences and based on the fact that he has been doing this over time. So he can teach other people, he can provide materials for other people to learn how to do the same. Then also he has he has come up with new recipe. So a new recipe in the sense that he develops something new that people will like. So it will taste nice in the to people. So as a result of that, because of his experience, he has the ability to create a new recipe and also a new book. So all these are part of what we call practicing over time. So the same thing applies to artificial intelligence. So artificial intelligence, you do this over time, learns from the past, learn from things, and then after a time, it becomes more better and better over the years. So that is what artificial intelligence is. So that's the reason why I said the scope is continues to emerge and continue to widen. So artificial intelligence is a field of creating machines that can mimic human intelligence. And when we look at machine learning, artificial intelligence has subcomponents. The first is the machine learning. And then what is machine learning? Machine learning is a subset of artificial intelligence where the machines can learn from data. So when you are talking about AI, there is a components that actually is working behind, that is working at the background, and that main component is machine learning, and that's why we can't do AI without doing machine learning. So we also have what we call deep learning. So a more larger part of AI, machine learning, is what we call deep learning. So deep learning is also a subset of the machine learning that uses artificial neural network to analyze a complex data. So in the machine learning, you can use little data. You don't really need much more data to run your machine learning. But for deep learning, you need a big data. You need a larger form of data to run your model. So when you are looking at this, we are trying to compare machine learning and deep learning. Machine learning requires little, data, and then deep learning requires a much more data. So the more data you have in the deep learning, the better the performance over time. Then also we have what we call a discriminative model. A discriminative model is when you want to distinguish between different categories or different classes of data. So you have various data mixed together, and then this time around you want to differentiate what data it is. Like for instance, you have a pool of people, let's say a mixture of boys and girls, and now you want a model that can differentiate the girls from the boys or boys from the girls. So to do this, you need a discriminative model. So all these are still part of the components, a subcomponent of artificial intelligence. Then we also have what we call the LLMs. We know of large language models. So the large language models are deep learning models that are trained on a vast amount of text data. Like I said earlier, you need large data to train your deep learning model. So, and it's a black box in the sense that it doesn't understand, it doesn't have a proud knowledge of the data it has. It doesn't have any information about the data. You don't really need to give it any information at all. And it learns from the data, from the pool of data. So that is where the LLMs originated from. So when we are talking about LLMs, you will see that LLMs have been able to train over the years a larger pool of data, a vast amount of data, which is the text data. So today we have the likes of ChatGPT, we have Gemini, we have Crocs, we have a lot of them. So it all comes out from the deep learning model. Then we also have what we call the generative model. Generative model has the ability to create a new data that is similar to the data they were trained on. So when you have trained the data, you have trained a model, and then you've trained the model using a data, and then you want to introduce a new data. So when you're introducing a new data, so you see that the model creates a new data for you entirely from a generative model. Let's say, for instance, there are different data of animals, different animals. Now, from that data called animals, different from some animals, it can generate what we call a specific animal for you. Let's say, for instance, dog. So it helps to create a new data that is similar to the data they were actually trained upon. So that is what we call AI. It's all encompassing, and it has a different segment. And the last one is the technology that powers the LLM chatbots. So that acts like an hybrid in between the LLMs and the generative model. That is the chatbots we have today, and people use that a lot to communicate and then to also have a feedback. So AI, as it were, it's all encompassing, and then it has different components. AI, the subcomponents is the machine learning and also the deep learning. And under the deep learning, we have the discriminative model, and then we also have the LLMs, we have the generative model, generative AI, and also we have technology that powers both together, which is called the LLM chatbots. So let's move to the next. Now, what is machine learning? Machine learning is a technology that enables the computer to learn from a given data and then make predictions. So we have some data, and then you want to do prediction with a new data. So what we do is you get this data together, and then you identify what the data is actually. So you give the model, you give the machine the different forms of data, what's the information of the data. So we call it the label. So let's say, for instance, you have various dogs, and then we have different breeds of dogs, right? So those breed of dogs, we just put all the dogs together in it as a data, and then you tell the data, you tell the you included in the machine in the data that we have 20 numbers of white dogs, or yeah, different forms of dog, would name it, and then we have 30 numbers of black dogs. So you could do that based on colors, and then you now tell the machine, you tell the model, you train the model based on the data you have and then the identification. So what the model does is to learn and then look at the edges, look at the colors, look at the features of each of those components and the names you have given. And then by the time you are testing it with a new dog, and then you are telling the model that I'm giving you a new dog, please, can you identify the color? So when based on the knowledge it has, generated, the knowledge he has acquired by training those dogs, and then based on the labels that you have included in your data. Now with this new dog, the model will be able to tell you that the dog, the color of the dog you are giving me is either black or white. So that is how it works. So that is what we call a machine learning. It helps you to predict, to make predictions or decision without being explicitly programmed. You don't need to program anything. All you just need is the model, and then put data into the model, and then helps the machine learning learns using the data. And after learning through the data, then when you introduce new data to it, then you can use that to make predictions. That is what we regard to as machine learning. Say, for instance, you have a training data, and these are data, they are in numeric forms. Sometimes it could be float, sometimes it could be integers. And then you have also your model. Your model is computational, right? So we have it in a computer, and then it runs on the GPU or CPU. Then you also have your new data. So after you have trained your data with a model, on the model, now you are introducing a new data to it, and you are expecting the model to train and then test, predict using this new data. So it can do predictions for you. And when it does this prediction, you'll be able to identify what data you have actually given it to the system. So this is precisely how it works. Then we can fine tune over time. So to make a better performance, and then using different metrics like accuracy, you can fine tune the model to get better performance. And then sometimes you can validate as well based on the decisions that you have. Also, you need to understand that both the original training data and the new data must have similar patterns in order to generalize well. When we say generalize well, so you are trying to avoid overfitting and underfitting. overfitting. You don't want a situation whereby the result is accurately, oh, it's outside of what you're expecting it to look like, or it is under on it's not performing up to. So these are the two things that you need to look out for. So one way to do this is to ensure that when it's learning similar patterns, and it's then able to generalize well. Now, I give an instance of a vehicle as well. Let's say you have a Mercedes-Benz, and then the data of a Mercedes-Benz, and then you have in a store, and then you have different, let's say you have a model, and then you have different patterns or features that you are looking at in the Mercedes. So in the Mercedes, you are looking at how many people have bought this Mercedes-Benz over time, and then you look at the location of where this car has been bought. You also look at the timing, and you look at the number, the age limit of people. So these are features that you can consider when you are looking at different scenarios. So in the scenario of sales data, you want to look at how these sales have been performing over time. So using the Mercedes-Benz as an instance. So when you look at it and you check over time what the sales has become, and then you look at some of the important features, like looking at the location where the vehicle is being purchased. You're looking at the color of the vehicle that is mostly purchased. You're also looking at the brand of the vehicle that is mostly purchased. So all these features you put together, and then you train it in a model. So when you train it in a model and you give it all these features, and if you're able to perform well, by the time you're introducing a new vehicle entirely, like say we are introducing a new vehicle, like say BMW, then based on the historical data you have, you should be able to, get something similar or something better or above what you've already had. So that is how it works, basically. So that is when you predict, and that prediction is using a new data to check what you are training on, what you have to check with the model based on historical events. So these are the features you will consider: the customer demographics, the pricing strategies, and the market trends. So this is a typical example of an AI machine learning. Now, the machine learning types, we have various types of machine learnings, and they are subdivided into three. So we have the supervised learning, and then we also have unsupervised learning, and then we have the reinforcement learning. So when you're talking about the supervised learning, we are referring to training a model with a labeled data. Training a model with a labeled data. So like I said earlier, you are having, different animals, let's say dog. And then the dog, it's a data. And then you are trying to tell the system, the model, that why before you train this data, I have some information to give to you. And the information is that I have two different colors of the dog. And the first one is black and the second is white. And we have 20 colors of white, and we have 30 colors of black. These are labeled, and then you are giving the system this. We refer to it as a supervised learning because it has a prior knowledge of what it's doing. So with this information, then the machine learning is able to learn with the data. And when it learns with the data, and then you evaluate the performance, and then now you want to learn with a new data. Now you are bringing a new dog, and then that is not identified. You are bringing that new dog to the model. Like, okay, model, please identify this dog. So the model, based on the fact or the events that it has trained using two dogs, and then it has understood the features of those dogs based on the label, the result that you have given it. Now, when you are introducing a new one, it will use those information to now predict to you what the new dog, the color is. So that is exactly what we got to as the supervised learning. Then we also have the unsupervised learning, is a model that is trained with an unlabeled data. So now you have a pool of, you have the dog. I will use the scenario of the dog. You have a dog. Now this time you have dogs rather. And this time around, the data you are providing to the model, you are not giving it an information. So you are not giving the model an information unlike the supervised where you give the data and then you are giving an information that we have this number of white and we have this number of black. But this time around, you are not giving any information. We call it an unsupervised learning. So what it does is that it uses different techniques to identify the dog, to identify the types of dog, and then be able to learn with those. So how does it identify this? So it does it by training those features. It trains with the edges and it looks at the ones that are similar and it brings those ones that are similar in clusters together. And those that are also similar on the other side, it clusters them together. So it gave it a own label, its own personal label based on its own discretion. Then when you're introducing a new data, it will now train that data and then you now compare with the event he already has. And then we now see the one that matches. So once it matches it, then you to give it that label and then we give you the results that you are expecting. Then we have the reinforcement. The reinforcement model take action in the environment, then it receives, model takes action in the environment, then also received a state about it gets a reward in form of feedback. So it creates a kind of loop. So it gives it an update and then it continues over time. So when it continues over time, it keeps learning based on the environmental factors and it keeps getting feedback. So the feedback will determine whether it's on track or it's in otherwise. So then it will be able to learn and adjust over time. So those are the three categories we have. Then the types of the supervised learning we have that of classification, we have of the regression. So classification, when you divide those into different clusters, then the regression is when you get a line across and you ensure that the clusters are around the line. And we also have the clustering, which is the unsupervised learning. And then we have the reinforcement learning, which learns from the environment and it states actions and feedback in form of a loop. So these are the three categories of machine learning that we have. Before we go ahead, I want to ask if you have any question before we move to the last slide, then we dive deeper into the answer. Okay, no question? All right. Okay, let's go ahead then. All right, so we have a model based on the machine learning type. So we have the classification, which is used when the output variables is a categorical. So we have logistic regression, we have decision tree, we have the random forest, we have supervised support vector machine, SVM, we have the k-nearest neighbor, we have naive Bayes, and we have neural networks. So these are type of model that you can find under classification. So when you're able to identify what type of model you should use based on whether it is supervised or unsupervised, then you should be able to use any of these model under the classification. And then sometimes it could be regression, and then if it's regression also, it has its own type. So for this clustering, which is the unsupervised, we have the k-means clustering, we have the hierarchical clustering, we have the density-based spatial clustering of application with noise, and we have the Gaussian mixture model. Then we also have the regression. So it's either use a classification or you have to use the regression. So the regression, we have the linear regression, we have the polynomial regression, we have the ridge regression, lasso regression, elastic nets, and SVR, and the neural network. So all these are the types of models that you can actually use based on the categories that we have identified earlier. So now we are going to do a hands-on, and then in this hands-on, we're just going to be doing a very simple experiment, and then we have requirement for this as well. But before we go in there, I want to ask again if you have any question. I think I see All right. So no question. Okay. Yeah. You can go ahead.
Yeah, thank you very much. Please, could you throw more light on the clustering? How does the clustering use the structured data, or rather, the to understand its clusters?
All right. Okay. So like, let me go back to the So, like for the clustering, if you look at the unsupervised learning, so look at the clustering. What it does is how it works is that I'm giving a simple scenario. Like you have I was using the dog for instance. So you have the dog, and then you didn't label the dog, right? You didn't give the model any information about the dog. So, and the dog comprises of black and white. Now, you just have those dog as data, and you didn't specify any of those dog. So now you want the machine learning, you want it to learn, and then because you want it to learn, and then using clustering. Clustering is one of the best approach you could use to identify these patterns. So now the clustering, meaning that it's going to cluster, that is group. Clustering means group. Is going to group together the one that has similar identity. So let's say those identity are features. And if let's say, for instance, the black dog, when you train the black dog, what are the features that you find? Do you find black colors? Do you find black texture? Do you find anything at all that could make make you to distinctively identify this as black? So it will also train the whites on label, remember, and then it will also look at those identical things that can differentiate it from the black. So once it's able to get something different between the black and the white dog, then what we do now is to train other of those type and then begin to group them together. So the one that is similar to the black colors, based on all the features, begin to group them together. And the one that are similar, that has the similar features or similar identity with the one with the white dog, then it begins to group those also together. So basically it will have either two or multiple different groups. So it could be two groups, it could be three groups, it could be four, it could be different forms of groups. So based on the matching factors or matching identity, is able to
Yeah.
group those together.
But thank you so much for that explanation. Please, could we wait until we've actually started the practicals before we start answering questions? Otherwise, you may find that you answer some questions which will be answered once you start the practicals. Thank you.
All right. Thank you so
Thanks
much.
so
All right.
much. Thank you.
So yeah, let's go to the practical section. Okay. So this is all we're going to do. This is the task. We're going to conduct a machine learning project that demonstrates any of the machine learning techniques. So it could be supervised, unsupervised, or reinforcement. And then you're going to train and use the model to make prediction on a given data set. So I'm going to I will send you the data set. And then also you're going to save the model, the trained model, and deploy it as a microservice in the cloud. So we could use different forms of cloud. Basically we could use any of these microservice. Then also the requirement for these tasks, we are going to have your IDs installed. So if you have a Jupyter Notebook or VS Code or Google Colab, so we are going to use any of this. So we are going to be using Google Colab because of its nature and it's much interactive. So, and if you can use any of those three. So I'm going to share the data set. So you download it, save it on the desktop, so that you'll be able to identify or access it. And then once you do that, then we'll go ahead. So this is the instruction, and then this is the requirements. Then also this is the data. So we are going to be working on the high-risk data set. So high-risk data set is one of the most famous data sets that contains data on 4 different attributes. we have the sepal, we have the length, sepal length, the sepal width, and you also have the petal length and petal width. And then he also has three different classes or species. We call it the Setosa, versicolor, and then virginica. So these are the three different labels. They are referred to as label or classes. Then each of those labels have 50 samples, meaning that in all we have a 150 data set, which is quite small. So the best approach to this is to use machine learning. So you can't use a deep learning because the data is very, very small. So it's going to be 150 samples, and then the different attributes has the attribute is measured in centimeters, and the data was developed by Ronald Fisher in 1936. So this can also be found in the UCI dataset. So I'm going to send the dataset to you, and then we'll start working on it. So look at this simple question: machine learning technique. What kind of machine learning technique do you need to use for this supervised learning? So, which is because you already have the label. You are giving the label. We are giving the classes, which is referred to as the label. So we call it a supervised learning. So in the supervised learning, like I told you, we have two different methods you can use. Is that you use the classification method or you use the regression method, regression model. So in this case, we'll be using the classification technique, and then you can focus on logistic regression, k nearest neighbor, decision tree. We can use any other one, LDA, SVM, and all like that. So we can use these three, and then at your own leisure time, you can introduce other ones. So this is what we are going to be doing. Then also the pipelines we are going to be working on. So basically, when you are developing a model, you need to have a pipeline. So the pipeline will help you to know what to do and at the appropriate time. So in this pipeline, these are general pipeline. Sometimes they are not inclusive, but most times they are all general. So the first one is to import your libraries and modules. So when you are importing the libraries and modules, you use the import pandas, import numpy, import the OS. The OS it helps you to work directly with the Python operating system. So that's why we import all the Python operating systems into your platform, so you'll be able to work better. So then we also have importing matplotlib. So you want to plot data there. You want to plot your data in form of histogram, scattered plots and all that. So you use the matplotlib. We have the import seaborn, and then you also need to, you can import warnings. Warning is modules. We have other modules as well as scikit-learns and all that. They are all modules, and you will see it as we progress. Then after the importing the libraries, you move ahead to loading the data set. So the data set, you have to identify the position, the location of the data set, and then you instantiate the data set. You instantiate the location and then give it a name. So df, that is the instantiation. So then you move ahead to pre-process. So when you are pre-processing, you want to make sure that the data is readily available for use. You want to ensure that the data is okay and it doesn't have any issues, because it's not just using any data or model. No, you need to, is your data, how well prepared your data is what determines the performance of a model. So when your data is well prepared and you ensure that your data is well established, I mean, you have made sure that all those questions are being answered when you're dealing with your data set, then that means your model will perform very well. So your data is the determining factor for your model performance. Please note that. Then after the pre-processing, then you go to exploratory. The exploratory now, you want to analyze the data. You analyze it in different forms using plots, using different statistical analysis to understand and explore what the data structure is. Then after that, you have to train the model. When you train the model, then lastly, you evaluate the model. So these are the general pipeline that we'll be using in the course of this exercise. Okay. All right, so let's go ahead. So yeah, just prepare your Google Colab. So I'm going to I'm going to send you the data, and then send the data out. Okay, send you data for
The data will be normally shared on the Zoom chat.
yeah, it's unable to share. Yeah, I think I need a admin to allow me share the data. Okay, maybe probably I should send it to the host. I don't know if that will
Yeah,
work.
send it to the host. The host can.
It's still giving me error. Unable to send file
Sorry,
due
may
to
I suggest that you share with Mr. Enoh, please, because the delegates on this workshop may not have the experience to actually take part in the exercise. We'd like you to just do the exercise amongst yourselves and to show us exactly what to do, if you don't
Okay.
mind. So if you share between yourselves and show us, that would be great. Thank you.
All right. Okay. Yeah, that's good.
Yeah, Prof, you go ahead, share your computer screen and then run the
Yeah.
practical. Yeah.
Okay.
When I begin to talk, we'll relate with them very well.
Yeah.
Thank you.
So thank you so much for that. So let me go to Google Colab. So you go to
You want to share, please?
yeah, I'm sharing already. Can you see it? Okay.
Not yet.
Okay. All right. All right. Can you see it now?
Yes.
Okay. All right. So this is the information. So the first thing you need to do is to load your data. So how do you load your data? You put it
Prof,
in,
just a moment. How did you come here? Maybe give them idea about Google Collabs and this tool. This is some may have experience, some may not have experience. So just give them general overview.
yeah,
That will be
yes.
important.
All right. So yeah, I'm going to share that again. Okay. All right. So yeah, Google Colab. Yeah, just type Google Colab and then go to this Google Colab and then can open a new notebook. So yeah, this is a new notebook. And when you get to a new notebook, you can rename this new demo, right? So now I need to, here, there's nothing here. So I need to import my data right into this place. So the first thing you do is you go to your, you put your data into the Google Drive. So once your data is in Google Drive, then you come here, you mount the Google Drive into this platform, connect the Google Drive. When you connect the Google Drive, then you allow it some time. Yeah, so the drive is up now. So you go to my drive. This is my drive. So I have my data sets on this. Yeah, it's on demo, right? See. So I have this high-risk data sets. This is a data set. So you go to this point, then you copy the parts. So yeah. So before then, you have to mount your data. So the first thing to do is to mount it. So now these aspects, you really don't need to let, yeah, you need some little coding. If you have an experience, fine. And if you don't, yeah, it doesn't really matter. What matter is ability to understand what you want to do. So the first thing you need to do is to mount. So mount the drive. So yeah, so you see, I'm not writing the code, but I only create a comment. So because I'm using Gemini, Gemini is linked to the Google Colab, right? Google owns Gemini and Google Colab. So as a result of that, it takes this comment as a prompt. So when you have a prompt and then you click enter, it suggests code that you could use. So this code is able to mount my drive right on the platform, on the Google Colab. So just click tab and then you run this code. It will mount it. And then all I need to do is just to connect it directly. So then go to the next step, next cell. The next cell, what you need to do now is following the pipeline. The first thing we need to do is to import our libraries and modules. So here you just put a comment, imports libraries and modules, right? And enter. So it suggests the libraries. So click enter. Then we have other library like OS. So let's see. So it's giving me a module. Let's see if it's going to give me other ones like OS. So imports OS, right? So these are all the libraries. So when you are done with the libraries, what else do you need to do? The next pipeline, the pipeline stage is to load the data sets. So when you want to load the data set, you go to the next cell, open a new cell by clicking this code or plus code. Then you put this comment. Then you write load data. Enter. Load data sets, right? Data sets. So loading. So loading should be df. Let's see. Maybe it should give us the code. Let's see again. So you can use this to give you more explanation. So you can see it's giving us a typical way you can actually load your data set. So what I'm trying to say is that you don't need to cram any code at all. So the Gemini helps you to, have your, do all those things. You put in all the codes even without knowing any of the single codes. So now the data, I can use df. I'm trying to instantiate. You can use df, then use pd, right? PD, and then use read, then CSV, right? Then I copy the data set. I copy the path. So you paste the path here, and that's it. So let's see the error saying I need to have df. So, all right. So yeah, there's something wrong with this. So let's see what we need to do here. All right, let's change this to okay. So let's see. Invalid syntax. So look at the syntax. This is where the issue is. So you have to put open and close bracket, and then you have your data. So yes, is df. So here we have df already. So you want to check your df. You just check the data. So here is the data. So we have 150 rows and we have 6 columns. And these are the species. And look at all these are the attributes. And then we need to remove this ID. We don't need it. And then this species, which is in object, we need to change it to, we need to encode it. So we'll be able to run a model. So let's just get 5 of it. So this is a simple, typical way of doing just 5 or bringing out just the 5 column. So now let's go ahead. So what do we need to do next? So when you've loaded your data, so what you need to do next is to check, delete, do some other thing, statistical analysis of your model, of your data. And then sometimes you need to do all the column. You have to remove the ID column to ensure that the data are well structured. So that's what we're going to do now. So the next thing we want to do now is delete. We want to delete the column. We don't need this column ID. So we have to delete this. So you're going to suggest code, and this is the code suggesting. So it's been, so not found in axis. Okay. Yes. So let's check the structure again, the column ID, and let's see what we can do. Column ID deletes the column. Okay. ID. Okay. Okay. So let's see this. So found in axis. Let's use true. Let's see if it's going to get that. So now if you're having errors like this, so you could use, when he's giving you something like this, so you could just copy it. And then if you have, just insert it here. So you don't need to, what you just need to do is just to use the DF drop. So we're going to use just the DF, the drop, and then use column instead of using the axis, since the axis is not being recognized. So we use the columns, and then we look at that specific column. So now let's use that, because that is what we can use to fix that. So let's do the columns equals to ID. ID. So PF, yeah, instantiating this. ID not found in axis. Let's see what's. Let's see what's saying. Okay, columns equals to EF drop. Okay, yes. All right, so let's run this again. Mhm. All right, so let's use this and see. They giving the error, so just
Prof, you can also print the ID column as well.
yeah, it's
So
printed.
to know the missing here. Okay.
Yeah. So yeah, we can actually print, which is let's just print it here and see. So we have, yeah. Okay, so actually DF showing, so the ID is no longer there because it's showing just these three and the species. So that's the reason why it's giving that error. So if you look at the DF now, right? So it's actually removed. So yeah, it's so surprising that it's no longer there. So yeah, so we have this now. So the ID is actually removed. So because we have this now, so let's see, let's look at the information that we have. Check the data info. So if you check the data info, we have 150 in each, and then they are all floats, 64, except for the species. So what we want to do now is we need to change this. Let's do the correlation first, and then after let's do the encoding and then do the correlation. Let's check the correlation, okay? So we want to do the correlation first. Correlation matrix. So yeah, because of this is a string. So is sorry, this is an object, so it's different from other ones. So that's the reason why it's giving us this. So now let's check. Let's remove the Satosa, and then when we remove it, then we'll now check the correlation again, because by the time we remove it, we can, removing it will help us to understand when we are creating the heat map, we'll be able to understand the nature of the data itself. So now let's see if we can remove species. So right, so yeah. So we have removed the species, the column of the species. So now we want to, so we have this correlation now. So we can draw the heat map of this and see heat map. So here the heat map tells us the correlation of each of those labels. So when the correlation is closer to either 1 or -1, then it's highly correlated, mostly correlated. So, but when it's getting closer to 0, and that means it's less correlated. So now let's move ahead and then change. Let's remove encode the original value of the species. So encode species. Okay. Back to, let's take our DF again. So here's the DF because we have removed that. So let's go back to the previous one with the species. So we have the previous one with species. So let's run this. So, species. So we coded it. So now let's check the DF. So we've encoded the species. So now the ID is showing. So let's drop the ID. Surprise. So drop the column ID. So drop the column. Okay. So it's removed now. Right. So it's removed. Okay. So now if you follow through the process, you will discover that we had from the pipeline. So when you have this, when you have the species, you have all the data sets. So now we've converted the species we've encoded it into zeros, zeros 1 and 2, which is the 3 labels that we have. So the next thing to do now is let's do the exploration. And then from the exploration, then we can now train the model and then we can test it. So let's do the exploration. Exploration of data. So these are counts. Yeah, we have similar counts. So let's draw histogram. Sepal and petal. So we have all the histogram. Yeah, so this is the sepal length, sepal width, petal length, petal width. So these are all the histogram of each of those data, each of those attributes. Now let's draw the scatter diagram of those scatter diagram. Sepal, petal. So we have the scatter diagram of each of these, the sepal lengths, sepal widths, petal lengths, and petal widths, and the same thing with the lengths and the widths from each of these. And then we have, since we have the species to be zeros, 1 and 2, so the first one is the setosa, the 1 is the versicolor, and the last one, which is the 2, is the virginica. So that is the label of the species. So now we've done the exploration. So if we want to look at the exploration, you see that we have 2 different data sets. We have black and we have a different color like purple. So you can see how the arrangement is as it moves from different lengths of the sepal and the petal. So this can give you an insight, and then you can analyze based on the diagram you have and do some analysis of this based on this diagram. So now doing your exploration, it can help you to analyze and then be able to analyze. So sorry, I will answer the questions later on. So now after doing this, so now let's train the model, and then after training it, then we can now perform the train the model and then do the model, and then we evaluate the model. So now to train your model, we need to number one, we need to split the data into two. We have the training data and the test data. So we have on each of those data, we have the train data, we have the data itself, and we have the label. So each label and data, we have train and testing. So that's what we're going to. So the first thing is to split the data into training and testing. Then after that, then we are going to use the model to train it. So now let's do that. So split into okay. Data, let's say data and label. So we have our data and label here. So the next is to split the data and label. Split data and label. So now we have different technique of splitting. So this is telling you that we have test size to be 20, while the training size is 80. So you can as well change it. So you can change it to 70 by 30, depending on how you want to randomly divide it. So then also when your random states shows that when you are using the random state, that you do it at random. Don't just divide it outrightly. So you have to randomly divide the entire work. So my time is almost running out. So let's quickly train and then we test. Train the data. So we are training with logistic regression. We have done this. Now let's test. Test the model. So we have tested the model now. So now it evaluates. So you see the evaluation is giving us 1, meaning that you have 1. That is the perfect one. So it's usually, yeah, you can make it 1, or if you want to make it like percentage, so you can just identify it here and say make it 100%. Sorry, 1, right? Okay, so percentage. Let's use percentage. So basically should just all right, so here you can see it's showing us the matrix. So each of these matrix, and then it's showing us the precision, different metrics. So we have the precision, we have the recall, F1 score, and support. So this one means that it's 100%. So that means it's near perfect. So that is exactly what it means here. So this is for the logistic regression. So you can do same for KNN. Let's use KNN. KNN model, right? So you have your model, you have trained your model here. Then to test, just test the model. So okay, let's see, evaluate, right? So here, this is also giving us 100, like 1 in each as well. So this shows that this performance is perfect. It's very okay and very good. So here you can see we've tested with KNN, we've tested with logistic regression. So let's test with decision tree and then we ask question. Decision tree, right? So then let's evaluate. Right. So here the evaluation shows you have accuracy of 100, right? Or 1. So this is the accuracy, which is 1. So here, this is what we have done so far. So yeah, because of time, we won't be able to move ahead to this. So I want to just entertain questions. So if we have questions, then we can quickly talk about those. And then I can give direction on what to do next. Okay. All right. I can see some questions there. Sorry, may I suggest we get through to okay. All right. Sorry. Okay. So has it already dropped the ID column? Yes, that's dropped the ID column. How can I be a master using this tool provisioned like this? Okay. I think Engineer John will dwell more on that. Determination, time, and commitment. Oh, thank you. That's one of it. Are you able to specify the exact ones you want to draw the histogram for? Yes, I did. Remember to stop. Okay. Yeah. So any other question? Yeah.
Sorry, I just wanted to ask a question. I posted the question directly to you at some point when you were trying to drop that ID column. Was the error message actually saying that it had already dropped it, and so it could no longer find that ID column, or what happened? Before you posted the print ID instead of the drop. Yeah,
Okay.
had it already dropped it, or what happened there?
All right. So I think it's already dropped it. So I think while I was doing drop ID column, it already dropped it.
Yeah,
So,
okay.
and
Yeah.
I'm trying to drop it again and it's not seeing it there.
Yeah,
That's the reason why it's
exactly. Yeah.
those
Yeah,
errors.
sorry. That was when I actually posted that question to you directly, that I think it's already dropped it.
Dropped it.
But then Mr. Enoh then suggested that you use the print ID, but I think that it already dropped it instantly after you posted the drop ID, and the error message was simply saying it can no longer find it. So it's already been dropped.
Exactly.
But
So the reason why he
thank you.
suggested for the print ID is for me to be able to be sure if the
Yes.
ID is still there or not.
Yeah.
So which I did, and I
Great.
found that it's no longer there.
That it was no longer there. Thank you. Thanks for explaining that. Thank you.
Yeah. All right. So yeah, because of time, what we are meant to do next is to save the file. So you save the model. So now we have a model. So we are meant to save the model. And when we save the model, we are now going to launch the model we are creating a platform like a web application that you can predict directly. You don't need to do all those. So you can go directly. So all you just need to do is give a specific parameters and then you will predict what the result is. So because of that, I would have showed you that. So that is what we are meant to do next. Then following up with that, because the Flask is one of the things we want to, you can use Docker as the microservice, and also you can use the cloud. You can launch it on the Google platform, Azure or AWS. So all these are what we do, and then we have various data you can launch as well, and on this. So these are things that you get to know more by the time you get your hands more on this. So I'm just going to ask Engineer Enoh to come up. Thank you.
Thank you so much, Prof, for walking us through the machine learning and at the same time the AI model. Guys, just to be clear, this thing is not a rocket science. Everybody can do it. You just need time and determination, just like Ibukun said. That is what you need to do. And let me quickly share my screen and then tell you. Sorry, can you see very well? Can you all see?
Yes, thank you.
Okay, thank you. So you need to understand when we talk about artificial intelligence, this is everywhere in the industry. And as somebody, either you're looking for a job or you want to do something new, it is your computer. It's computing with you. And as a result, you need to know the tool. Not only knowing the tool, you need to know how to build it. That is what Prof. Dr. Idowu just mentioned to you in a couple of times. We run a 4-month program, which is, we call it accelerator program. We either switch you on or we edge you up. That means if you either had a skill before or from ground zero, we can make you within 4 months, just Fridays, 2 hours, Saturday, 2 hours, and then build you up within 4 weeks. But that is not what I want to talk about. What I want to tell you is that this is actually very simple. What he was doing is how we build models to be able to do either like similar to what ChatGPT did, OpenAI, did, Google did for Gemini, or every other thing. You need to understand that AI is transforming industry worldwide, in any industry, either in the agriculture, in the healthcare, in defense, wherever. And as a result, whoever you are, you don't need to be an IT guru to know AI. It's a very easy tool that you can study, right? And 85% of businesses will integrate AI into their operation by 2027. In fact, businesses that don't integrate AI into their operations may be facer. It's just you looking at the computer today and then the typewriters of those days. And so AI literacy is essential for career growth and for career switching or edging up. What you need to know also, AI is now becoming an employee as well in many of your companies, okay? And I will be telling you that very soon. And you can take part and be part of the revolutions that is actually happening. Just in a quick flash, I want to tell you, you can future-proof your career by learning AI. What Prof was just telling you right now, these are the people we call the AI and ML engineering. They earn almost $250,000 towards $800,000 per annum. No question about that. If you know how to build model, just what Prof was just doing, if you know how to build those things, company like Google, Meta, Microsoft, and the rest, they are looking for you every day to know people who can model data and then be able to build them or architect the type of this system in an augmented way that can mirror the intelligence of human and begin to build large language model or what we call language concept model. There is a new architecture in the industry which was just came up now. Beyond large language model, we now have what we call large concept model. Large concept model is that where you bring real human intelligence or reasoning into agents and stuff like that that are able to do autonomous tasks, carry out tasks on behalf. We also have AI-powered cybersecurity as a role that you can look for because you need to understand that since a lot of data are coming in, there are a lot of data attack. So they need people with AI skill to come into this. We have enterprise cloud and AI cost optimizers, a lot of that. And then not only knowing one cloud, you need to be able to know the different cloud, either AWS, GCP, Microsoft, and the rest. They are all the same thing. It's like building a room. You need to understand the setup of those rooms. Beyond that, there are what you call the decision intelligence and AI enhanced analytics. Maybe these are data scientists or business intelligent people that can understand the data, provide executive decision for a better performance. Beyond that, we also have the AI infrastructure and machine learning ops that build a kind of support the deployment, the orchestrations, or deploy them on the GPU or TPU clusters on the various cloud as well. Of course, then you have the advanced robotics and autonomous system. People that work in like autonomous industry, either autonomous plane or like you have Tesla's vehicle in in San Francisco or even in Austin or in Dallas, where I am. And then even in the healthcare industry, a lot, AI is everywhere. And as a result, you need to know AI. You can also use it to actually know how to find a job. In fact, if I'm looking for a job or somebody's looking for a job, without spending your own time, you can ask AI to go look for a job and map it to your resume and even submit the resume on your behalf. So you can do a lot of all that, and you don't need to be a guru to be able to do this as well. You can do job search for you. And that is why I'll be talking briefly about AI agent. AI agent is very important that you can build that is mimicking human to be able to carry out tasks for you. When we talk about agents, of course, this is only 2 hours. A lot of time we need to be able to coach you on what to do. And again, you can do it. In fact, whoever you are, you don't need to be a programmer. You don't need to read computer science to do this. You can do it. You just need to follow certain rules and guidance to be able to do that. You need to understand AI agent very well, because some of you here, AI agent is already competing with you in your place of work, either doing a lot of things wherever you are working. In fact, in the UK, in the US, wherever you are based, you need to understand AI agent, which is an AI employee, is actually competing with you already in the place of work. You need to understand them. You need to know how they work and the application, and even the different use cases as well. And then being able to even create them yourself, either in terms of memory, what we call a kind of memory, putting them in memory using different type of data, either text data, video data, audio data, to build them. We have a program that we do this within time. And then beyond that, when we talk of agents, agents are software programmed actually to perform tasks autonomously or semi-autonomously. That means sometimes you need to give little input to it, or you don't do anything at all. Okay, imagine AI booking. Of course, some of the meeting, it books it for you, it schedules a meeting for you. It does a lot of, even draft email and send to somebody to follow up. We have AI agent today that can do a follow-up call, have real-time conversation with human being as if it was person. We also have AI agent with voice cloning that can clone my voice to do what I normally do, maybe a kind of repetitive type of action from time to time. So when we talk about AI agent, we program the computer using large language models such as what Professor Idowu just mentioned to build this autonomous tasks. They can interact with users, process the information, and make intelligent decisions as at when do. And when we talk about agents, we have different type of agents. We have rule-based. That means we define certain parameters for this tool to follow. Then it is also, of course, a machine learning-based tool, just using data, follow the definitions of that. Then sometimes we combine the two which is a hybrid of agent. And when we talk about agent, you know most of them already. We process autonomous tasks, they process them, and then we have what we call the assistants, AI assistant, which is not fully an agent, but they just support you to do your tasks. The AI agent work autonomously, right? You don't need anything to make it to work. You don't need to even interact it much time. You have the chat bots today, most of the chat bots, and autonomous vehicles around there. Most of them are agents that have been programmed. There are tools and work frameworks that are AI models and libraries that are used to program them. In fact, you have library from popular company like the OpenAI, generative pre-trained models that you can use, which is a text-based application to even build an agent. In fact, last week, OpenAI released what we call software development kit that you can build an agent. In other words, if you can replicate yourself using AI, using all these models, you can replicate yourself. You can even make yourself to go do some work somewhere. For instance, you can become a social media manager for a company. Meanwhile, you are not literally there. You can build a tool to do those things for you. Those are all done by AI, and there are tools that are already existing, models that have been trained over time that are already working. We have the Anthropy as well. We have the Google Gemini. We have Llama and the DeepSeek also. And of course, there are various technology and AI development frameworks, like I mentioned earlier. We have the LangChain, which is a framework for powering chatbots and various applications that you want to build. We have the AutoGPT tool, and then the baby AGR. That is AGR we are talking about the autonomous system, that is artificial general intelligence, such as the manual that the Chinese company just launched, which is wonderful. It can actually do research for you, can write journal for you, can do a lot of things beyond ChatGPT. Those are multi-system agents that can do a lot of that. Then we use technology to like retrieval augmented generations. Just like a library set of books, we put it together, filter the information, and bring out the specific answer that we're looking for. So these are the technology that we use to power our agent from time to time. We also have memory-enhanced AI application that can store and then record the past interactions from time to time as well. There are use cases. One of the use cases is the AI customer agent. When we try to define an agent, we first of all define the use cases. The use case can answer customer query or do troubleshooting. Say you are an engineer like myself, you have what we call method of procedure. This method of procedure can be transformed to become an agent to be able to do that. In fact, when Professor Idowu was talking, he has an error. He has to put it on a portion of the Gemini. That part of the Gemini was actually acting like an agent, helping to troubleshoot the query and giving him a hint on how to fix the query. In building an agent, you need to also select what we call an AI model. There are many models that are out there already. The OpenAI GPT for natural language processing is actually there online that you can actually use to build an agent. I'm going to show you that in a while. And beyond that, you can also train your own model. In MVIT, we train a model, which Dr. Idowu, of course, is supporting very well, not fully launched yet, but we are training a model to be able to look at the utilizations of users of the cloud computing, the computer, the GPU, the central processing unit, the memory, how much you are spending, and to predict to you how you can reduce your cost. We also see that you can integrate this tool to other interfaces like WhatsApp, Slack, website, like you have Widget already on some website. If you go Nobody is there. You're just chatting with, and the thing is answering you. In fact, right now, it can even make a call and even pretend to be like the person that you actually need to talk with. Have detailed conversations in a driven way. And this can be deployed to the cloud as well. And so we define it, we select the model, we train it, and then we can do our integration, and then we deploy it. Another thing also, you can have an agent to become an even investment advisor. Any role that human being can play, AI can be trained to do the same thing, especially roles that are repetitive, that has a certain definitions, that has clear data on how those things are done. So it can help you, can gather financial data from via API application programming interface, and we can use models to analyze historical trends and predict future movement, similar to what Doctor was trying to explain for you earlier. So if you are either a developer of this AI tool or a model builder or a fine tuner, that means you can fine tune the model to make it better, or you can be an architect designing how it is going to be deployed, what technology is needed at one time and why, how the performance will look like. So there are many roles. Even if you, for instance, if you're a Lego person, there are ethical responsibility. You can become an expert in terms of ethical side of it. You can become an AI. You learn how to bring business intelligence, because the way AI is trained, we still need the human brain and the human skill. And the thing is that if you are not learning AI, AI will replace you. That is just a simple truth. But AI cannot replace you if you know certain rules and things like that. And then, of course, it can help to implement a risk assessment, an algorithm for investment recommendation. In fact, people are in Wall Street today that use AI tool to tell them, okay, this stock is going to crash tomorrow. You need to invest in this. Don't put your money here. Pull out money from this investment and brings down. There are AI models that are advising investors in Wall Street and many of the market in this world today doing that. So you can develop a user-friendly interface for displaying investment insight and for continual update of the model from time to time. So we see various use cases in the industry. This is just to demonstrate you gather the data, you use AI model that have been built to analyze data, you do the risk algorithm assessment, you also design all that. Even for recruitment, right? Collect job descriptions and candidate resume. If you are a recruiter, you can build an AI agent that can help you to do your job, to become very, 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 very productive and do this job in a very wonderful time and very fast time. And this AI is using what we call the natural language processing to match candidate with job role. Not just using going to LinkedIn, no, not that, not just using keyword, but they are using different type of predictive analytics or a kind of descriptive analytics, or even what we call pattern algorithm, to be able to look at various jobs, rank it, and say, okay, this is qualified. Don't waste your time here. Interview this student, this candidate, and then even schedule all that for you. So in other words, AI is competing also with human resource people. So you need to know them. You need to know these two very well. When you know it, you become the master. For lead generation, you can build an agent for lead generation. You can identify audience and data source and target people that you need to reach. We build AI tool to scrape the internet, scraping the internet to collect data and tell you, okay, these things that you are selling or these goods that you are selling, you have a user B who need these goods, please quickly look at that. And that is why all the advertisement, Facebook and the rest are placing. In fact, they are using tools like this very well and even track the user's behavior, either on the web or even use what we call the Internet of Things. That is just a simple diagram there. Even for health, I think we will find time to, if you can see, if I can show you this. We have a health fitness and planner. So we can collect data from the internet or anywhere and match what type of food or lifestyle you can live. You can use AI to generate a personalized workout and nutrition plan. You can do all that. So things that are very, very peculiar to you can be done. So you think of various ways. And so if you learn AI, one good thing is that you can easily create a job for yourself, or you can create a side job by an agent. We have people today that build an agent. They are still working wherever they are working. An agent is also generating revenue for them. It's a tool. It could be, we call it AI agent as a service. Because if you build an AI agent, maybe you have a very good idea as you are even talking, you can put it to become an agent. Within a few weeks, it's there and people are subscribing to it. It's also a way of generating revenue as well. And it does a lot of this. Like this AI agent particularly, I think I will see if I can have time. Okay, let me quickly go to the practical side of thing. There are different use cases in the travel industry. Even for movie production, it can guide you to generate script the way you do it. In real estate, it can be built as well. So any area that you are thinking, AI can actually be done for you. Even in ministry, wherever, whatever you are doing, AI can actually do it for you. I'll quickly go to the demo, but just a quick one. This is the link to the different program we offer, and particularly for the AI Accelerator program, this is the link to it, mvit.tech/AI-ML-accelerator. You will see the module there. We have a class ongoing and it has been wonderful. You can come from ground zero. We will train you. But before we take more questions, I just want to turn on my tool and then show you an AI agent. And this is Microsoft Visual Code. It is used to run or deploy agent similar to the Google Collapse. Okay, and I'm using this. The AI agent, I have a lot of them for training purposes that we do, but let me show you the one for fitness. The one for fitness, or let's look at the one for fitness and then try to look at that. The fitness will give you a plan, the type of a plan you want to do, to just make sure that everything around you is okay. Let's quick. I have a lot of them, but let's look at the fitness. This is a fitness agent, okay? So this is the fitness agent. Let's look at the README to understand. And this agent is a personalized health and fit agent. It's powered by a framework called Angle, which is a Python framework. And this agent will generate a kind of tailored dietaries and fitness plan based on the user input, such as age, the weight, the height, the activity level, the dietary preference, and the fitness goals. And this type of agent, what happened we are doing now is going to scrap everywhere well-known research that are out there to predict what you need to do for you. So that is the README for the agent in terms of the fitness agent, personalized dietary plan, fitness plan, and then you can ask like a follow-up question, okay? And so I'm going to run this agent now. So we have a tool, okay? And in that tool, sorry, I'm trying to get the name of the file. Okay, name is change. Okay, so I will now run the code. Let's just run. It's not existing. Okay. So you can see, I have an error. So, okay, need to install that. So at any given point in time, it tells you what to do. Install it, okay. So this is the agent that we have built. So, but we have to, this agent is connected using the Google model, right? So now I need to get an API key from uh, Gemini. So I'll go to Gemini. I need to get an API key from Gemini. Sorry. So I'm generating a key, which I will use to test my agent. And what I have just done is that it didn't take me time. I have an agent, but it's the Google model that is going to make that agent to run. I'm trying to generate an API key so that I can use. Okay, we have a lot of questions. Sorry, it's taking a bit time. Okay. So we need that. So we need that key. Let's see. Yeah. Let me see if I have an old one. Okay. I think I have an old one. Let me copy the old one. This is wasting time. Okay. So I paste the key there, right? So you can see, let's say this is 40. This is the number of page. And then we are saying in kg, the weight is 83. Maybe let's say that the height is 150, whatever, male, okay? And then we want to look at the activity level. Let's say very active. And then in terms of fitness, what is the fitness level that we have set? We can say the stay fit. And then the dietary level, let's say that is dietary free. And then what happens is that it goes everywhere based on this information I've given to it to give me a plan of how you need to live in terms of what you need to follow. Why this plan? It tells you, it gives information about high protein, high fat, moderate carbohydrate, and all that. I'm not a medical person, I'm an engineer. But again, it gives you a plan of your meal plan, what you need to eat, how much of it you need to eat, and everything. And if you want to, and it gave you a lot of tips as well. So you can actually use agent to build whatever you want yourself. And you can add a follow-up, help a follow-up question. I need some general advice as well. Okay, and then it can give you a kind of a more information. This is an agent tailored for fitness and other things like that. You see, giving a follow-up question, giving guidance based on specific. So we use agent to do a lot of things. Now we have few minutes. We want to use this time now to take questions.
Please, could you share the link to your training platform on the group, please? Because we can't click on the one. It's a bit hard to copy what's on the slide. Yes, thank you very much. Thank you.
Where do I need to put it? On the LinkedIn?
Just on the chat, on the Zoom chat here, so I can click directly from here, the Zoom chat.
Okay, thank you. I'll do that now. Thank you. Okay, I think you should have it now. Is it on the group already?
Yes, thank you very much. Interesting.
Okay.
Thank you so much. Thank you.
Okay, thank you. So any question for us, please? I think I have some question here. Okay, which of this career is the accelerator program model to cover? The accelerator program is modeled, the acceleration program is actually focused around becoming an AL and ML engineer. But again, once you know that, it's like the superpower, and it's anybody can get to do that. It's just 4 hours per week, and then you are able to do that. Then I have another question here. You need more than the actual, okay, the problem. So, okay, Dr. Idowu answered that already. Okay, Dr. Idowu, I think you did answer that already. What is the lowest hanging fruit for a career in AI? The low hanging fruit is actually knowing the tool and quickly knowing the tool that is not very common, is still growing, right? Especially knowing this agent, which you can just know how to use the tools, like learning to use software. It is very, very key. And again, too, another low-hanging fruit that can tell anybody right on this call, look at the problem where you are, the everyday problem that you are passing through, either at the place of work, and see how that AI agent can be built. By the way, we built an agent too. Within a week to two, we can deploy an agent for you. That is that. And then we can also guide you to build it by yourself as well. Can you help post the link?
Our career will be called AI agents.
Sorry, say that again.
So will we be called AI agents, or what will be the career? What will be my title?
Yeah, you can become an AI agent manager or even a developer, which every company is actually looking for right now. Because what is happening, especially as a result of why we talk about agents so much, is that it's like your competitor at work. In fact, in Microsoft or in Meta, about 60% of software developers are not human beings, they are AI agents. And that is why people like Mark of Meta will say that he is able to lay out some either junior staff or even experienced staff, because the rest of the staff are not human beings, they are AI agents. And it's going to happen across. A time will fail me to talk about it. In fact, I have AI agent right now that help to do my work as a solution architect. It goes about when I do a work, to go and check competitive type of architecture to say, okay, which is the best? We have AI researcher. It doesn't necessarily replace the human researcher, but you make you to do better and to do more. So you learn the agent. And if I go back to the place where I was talking about, there are various ones. I just mentioned there are a lot of roles. Some people are lawyers. In fact, the best you can know right now is to know the AI ethics. Because when we train the model, we say it should behave that way. It could be against another type of thing. So you need to know the techniques where you can also support in that level as well. Or if you're a business analyst or you are a project manager currently, these are the things you really, really need to do. In fact, for many of you that do 1 or 2 jobs, you can actually do 6 jobs at the same time with the help of an AI agent. Okay, so the profit or the opportunity is a lot, you can learn. So, and the truth is that you don't need to go to school for 4 years to do this. We can guarantee you that doing our program here, actually, you are okay. We have students that we're training, and it's wonderful. And we can plan it to also jumpstart a very good time for you. Have it well recorded and all that. Once again, I want to appreciate everyone for taking time, especially for helping us to be part of your team tonight. It's a wonderful privilege. We're looking forward to actually work with you going forward, and we are available to support, because we believe that if you know AI, there is nothing like racial discrimination or anything. If you know it, everybody is looking for you, because it's a problem. It's a problem that must be solved. Companies are looking for solutions. If you look at it right now, even in the big tech industry, they are fighting which model will be better, and they are looking for AI people to be able to do that. So it's one of the areas that you want to quickly, as much as you can do, to move on and quickly get insight into them. Thank you so much for your time this evening. If there are no questions, then I'll pause it.
Yeah, there are questions.
Yes. Sorry. Before you go off, I mean, once you've answered the questions, I'd like to just summarize, please, and just reiterate some points which you haven't stated there. But in terms of the slide decks, no, the actual video will be shared on the Ladder Back Down slides, but sorry, on our website, on our YouTube channel. But I always emphasize that the slides are actually the intellectual property of the presenters. So if you want to review the slides, you can easily go back and watch the video all over again. In terms of when the next accelerator program is starting, please take a screenshot of this actual last slide that is on the screen now and reach out to Mr. Enoh and Dr. Idowu directly for that, which leads me into something that I was about to say, which I should have said at the beginning of this workshop. So the Ladder Back Down partners with organizations like this organization. We collaborate with them, but we do not receive any money or anything for referrals. So just making it clear that the sole reason we've brought this program on, or we've put this program on tonight, is because we actually believe in the fact that if you can take that time out to learn artificial intelligence, then you will have a bright future, because rather than stand and keep saying, oh, AI is going to take all of our jobs, which is a widespread saying nowadays, why not actually work towards making sure that AI doesn't take your job, but you actually understand artificial intelligence and how it can help you to do your job? I understand. I know that Mr. Enoh touched on it very briefly there, where you talked about, but if someone can just scroll back up the chat to my reply about the low-hanging fruits, the lowest hanging fruit for a career in AI. I've said that if you're not a programmer, if you're not a developer and you don't want to learn Python, then start looking along the cyber route. If you work in cybersecurity or governance or ethics or regulations, there are many opportunities. I will be signing up for this training because I already did the AWS AI practitioner paper last year, as well as an ethics paper last year, because I recognize that regardless of my experience, the fact is that artificial intelligence will be easing people out of their roles if they're unable to actually say that I know how to use AI to do my job better. If you're a lawyer, you need to understand artificial intelligence. You can use it for research. If you're a healthcare professional, trust me, they've been using artificial intelligence for robotic surgery for many years. So there's no career that you may want to actually get into where AI will not make you more efficient. So again, whilst I'm not receiving the ladder back down, or me personally, we're not receiving any money or any bonus or anything as a referral fee, I'd encourage each and every one of you to not say that this looks too hard or it looks too complex. The fact is that life is complex. There's no easy career nowadays. There's no career where you can simply stroll up and simply say, I'm here, I've got a degree, so I deserve a job. There's no such career nowadays. So please, if you're interested in exploring more, reach out to the company. If you can put the email address back on again, please, for everyone who wants to reach out to you, email address or via WhatsApp, reach out to them and simply just get involved, because there's no point simply just standing by and wondering why we can't get into those roles, why we can't progress, why we can't be promoted, or why we can't even get an entry into a career. It's because companies are trying to do more with less. And that less includes artificial intelligence. So instead of wondering why you can't get in to become part of that less, embrace AI. That's what I've got to say. Thank you.
Thank you so much. Thank you. And that was wonderful. And again, we do appreciate you very, very well. Any question for us again on the call, please?
Can I just add, because somebody asked question about the job titles, and I think for me, something massive jump out here. So if you look online, I know AI is not anything that I've really kind of focused on, but this is a big eye opener for me, because I'm in the contract position and I've been earning inside of IR35, and every day I scream at how much is being taken off my salary, and just looking at business analyst AI, and I'm seeing, loads of job around 650, 700 outside of IR35. I've never paid attention to AI career, and I can see AI engineer, AI developer. So I think it depends on what you want. Even cybersecurity AI is all there online if you just Google, depending on your location. So I've had to use London, and I can see loads of AI job coming up for outside and inside of IR35, but majorly outside if you're contracting, and quite a lot of permanent job as well. So I think the person was asking about the title. So there are so many titles depending on how you want to approach this or what your background is. But thank you very much. Is an eye opener for me, and I'm definitely going for the course as well. Thank you.
Thank you so much. And then just to add up to that, right? One key thing I've also seen in the industry, especially in the US and in most other places, I mentioned agent particularly. If you know You may not know how to build, but you need to know the tool that have been built and they're doing great things outside there. In fact, you could be working in a place where you don't have full understanding of, an AI become your companion, a team player, or a partner, right? It's like taking a job, you don't have complete understanding or capability to fulfill that job. The AI tool can actually support you to become an expert in that domain too. It's actually used in that form as well. So you need to look at it. It's a very, very big opportunity if you know what you want to gain from it. And again, it's a very short time to explain everything, but we are waiting for you, as many that will be taking the course, to really support you to get doing great, great things out there. Once again, I really appreciate you and thank you so, so, so much. Okun, we really appreciate you for your time.
So excuse me. So I don't know if you can hear me, please.
Oh, okay, Shola. Oh, go back to you. Go ahead, please.
Yeah. Sorry, please. I came late, to be honest. I just came in about 15 minutes. I was quite busy doing something else. But so far so good. I've really saw the slide that you did while you were strolling, and presently into I'm into IT. I'm a security architect. But presently I'm running a master's on AI. So
Okay.
yeah, and when I got this link, I think it's a very good opportunity to know more about AI generally. So I just want to ask, yeah, is there a way that you can work around AI without you knowing Python? Is it possible?
Yes, it's very possible. You don't need to be a guru. In fact, many of our students don't know anything about Python. Some came from art background. They don't understand Python. See, it's we look at you, we work with you to understand your interest. The thing AI is doing is like looking for intelligence, like your critical thinking, like your decision making. So when you look at that, there are various roles that you can play. And particularly, what are you doing as of today? So I could decide not to even do anything like modeling at all. You'll be dealing with Python when you try to model the data. There are people that do what we call annotations, or the data labeling is also skill. For instance, data labeling, that is for supervised learning. Before an engineer can do that, you have mango, you have orange, and that type of fruit.
So classification.
Yeah, you can do a lot of classification, categorizations, and all those type of things, because it's not one person that build an AI model. There are people that does labeling. There are people that do annotations.
Yeah. So this is why I'm asking this question is because why? Because I'm going through with the course in June. Yeah, but why doing this course? I do notice that almost every course that we do has to do with Python. Trying to use Python to extract data from libraries, trying to use Python to cleanse the data, and use Python to start performing things like regression, or maybe trying to, depending on the method that you want to use in doing your modern transformers and all those kind of stuff. So I'm just thinking, because I'm not very good with Python, I'm really, really struggling. So I'm thinking, I don't think I'm going to go ahead with this AI thing anymore. Why? Because everything I'm doing is just around Python, and that's why I'm asking this question.
So I want to encourage you, please stay there. The only thing maybe you need a second opinion, right? So maybe from us. I don't know if you still have time to take our course, but we can guide you to support. I advise you stay there. It's not a rocket science. Whatever they are calling there, right? Even you can see when a professor in this domain, he didn't even introduce himself very well. He's a professor of artificial intelligence. That is what he studied. Okay. And so what I can tell you is that when he was looking at it, he even has an error. He went and used an agent by the side to guide him to do it right. So I want to advise you on a personal note. Please stay there. You may want to take maybe this our program, and then we can guide you the more from.
So what are the prices of this program, please?
Let me quickly share that.
Sorry, rather than share the prices, could you just email the company directly for that, because we don't
Okay.
actually allow for sales promotions here. So if you
Okay.
could directly email, but based on that gentleman's question, doesn't natural language processing actually reduce the need for programming skills or coding skills in AI?
Yeah,
Yeah.
yeah, I do natural programming language at the moment, and it's
Yeah.
still we still have to go to labs to do the coding and all this kind of stuff.
Okay.
Yeah.
Let me give you advice. There is what we call no code, low code, no code, or even no code at all, right? What you need to do when, for instance, if we have time with you, we will advise you on tool you need to use. So you don't need to bother. But the only thing is that many of the large language model out there, the AI tool, were actually built with Python. So there are Python library like TensorFlow or PyTorch or
PyTorch, yeah.
Pandas, NumPys that were used, because these are mathematical models built with statistics and R programming that you need to call in to either plot a graph for you based on what you want to do, right? You need to call because it takes time to build them. So you need to know when you need to use them. Those are the things that we will guide you. But I can tell you, we can guide you about that. Thank you.
Thank you very much.
So I would love you to do a course with us, okay?
Yeah, I'll get in touch.
Okay, thank you.
Yeah, so I think it's important that if you're interested in learning more about any pricing or anything, as I said, the ladder back down isn't engaged with any companies to negotiate pricing or anything like that, and we don't receive any referral fees. So please just note down this email address and discuss with Dr. Idowu and Mr. Enoh, Engineer Enoh, after this workshop. Thank you. Okay. Any further questions, or could we call it quits now? Could we call it a night?
Yeah.
Okay, thank you to both of you so much for sharing with us of your wealth of knowledge. I'm always particular about gaining knowledge, and I'm sure that everyone that's joined us here tonight as well has learned something from you. So hopefully people will be reaching out to you just to discuss what you've got to offer over the next few days. But I'm also sure that some people have gained things from here tonight that have been an eye opener to us. So thank you so much for that. Thank you.
Thank you. We really appreciate you. Thank
You're
you.
welcome. Thank you. Thanks.
Thank you.